So now we're going to talk about the zero of a function. The zero of a function is when the function equals 0. So sometimes we want to find the zeros of a function. So that's what we want to do in part A here on example 8. So they give us a function, 2x squared minus 7x plus 5. And to find the zeros, we just take the function and we set it equal to 0. Now we're going to do this problem like we did the other quadratic equations that we've been solving. So it's going to factor into 2x, I think I can just do this with trial and error, minus 5 and x minus 1. Now, I did it by trial and error this time. Does it check out negative 5x and negative 2x? Yes, that equals negative 7, so it worked. Okay, now I want to recopy it, I guess. So 2x minus 5, well, I'll do it easier than that. I'll save a little bit of room. So 2x minus 5 can equal 0, or x minus 1 equals 0. And so we get, for this one, 2x equals 5, or x equals 5 over 2. And then for the other one, we get x equals 1. So when it says find the zeros of the function, they're talking about taking the function that you have and setting it equal to 0. And so you're going to get two zeros. The zeros are 5 halves is one of them, and the other one is 1. Now think about what they are as ordered pairs then. As ordered pairs, they are 5 over 2, comma 0, and 1, comma 0. Now, if you think about graphing those 2 points, so I'm going to go over here because it's going to go right along with this. So where is 5 over 2? 2.5, right? 1, 2, 3. So it's like right there. That is an x-intercept because it's equaling 0 for the y part, or the f of x part. So think of this as x and f of x. And so it's right on the x-axis. And so it's a 0, or you could call it an x-intercept. And then the other one, this one, 1, 0, that's right there. That's also an x-intercept. So when we have these quadratic functions, a lot of times they want us to find the zeros or the x-intercepts. But it's really the same point. You just have to write it how you're going to write it. So we're going to write the x-intercepts as ordered pairs. So the x-intercepts are 5 over 2, 0, and 1, 0. Okay? And then finally it wants us to find the y-intercept. Well, to find the y-intercept, you take your function. I'm going to have to try to remember what it was here. So that was the original function. And you're going to let x equals 0. So you're thinking, what happens if x equals 0? So you're going to evaluate the function when x is 0. Well, you're going to get 0 here. 2 times 0, it's going to be 0. You're going to get 0 here. So you're going to get 5. So the y-intercept is going to be the point 0, comma 5. Which that point, if I were to go over here on my graph, 1, 2, 3, 4, 5, it'd be like right there would be the y-intercept. So by doing this later on, when we actually do the graphing of these, you'll be a little more familiar with it because you know how to get the x-intercepts and you know how to get the y-intercept. Now, I know this is the first example, so we have to practice them, and we will later on too. Remember, when you want to find the x-intercept, let y equal 0, or f of x if you're using function notation, f of x equals 0. If you want to find the y-intercept, let x equal 0. Okay.